Thank you. All right, so we're going to learn all about PDB today. Who am I? I am Clayton Parker. I'm the Director of Engineering at 6 Feet Up. I'm also known as Claytron throughout the internets. So if you want to know what code I'm writing, what music I'm listening to, beer I'm drinking, whatever, it's all on the internet for your consumption. Also on Twitter or whatever if you want to hit me up. I have a lot of slides, so we'll try to get through them all and maybe get to some questions. Who in here has never used PDB? That's a lot of hands. All right. Who in here has used PDB? Even more hands. Good. All right. So for those who raise your hands first, I hope you learn a lot and apply this knowledge as soon as you get back to your day jobs or your pet projects. So PDB is the Python debugger. It's in the standard library, so it is available wherever you're programming in Python. It is an interactive debugging tool, similar to things in other languages like Pry in Ruby or I forget the one that's called in PHP, but it gives you a way to sort of look through the code without having to resort to print statements and things like that. And it is also pure awesome, in my opinion. I use it a lot. If I have any questions about what I'm trying to accomplish in the code, I jump into PDB. So first thing we're going to talk about is how to invoke it. So two common ways, or probably the most common way, is just to do import PDB and then do a PDB set trace. So if we go to the terminal here, so first I'm just going to run this command I have, and it just runs and gives me some output. But if I want to, well, here I can do the PDB set trace. So if I edit that file, and let's say we're curious as to what year it is, we can just throw PDB in there, save that, and then this time when we run it, we'll actually be pulled up into the PDB prompt so we can start debugging our code. So that's one way to invoke it. We can also, you can actually invoke it straight from the command line using the -m flag, which runs a module. So in this case, it's going to run PDB before starting our script. So if we look at that, and there's also other cool things you can do with the -m flag, but I don't have enough time to talk about that. So we'll run this. And so this time you can see we're at the very beginning of the script instead of inside of the main function. So this just starts your script directly in PDB, and then you can start it from there. So if you have a command line script that you want to debug and you don't want to edit the file, you can just do that quickly to get in there. And it's a little harder to get out of because every time it gets to the end, it's going to loop through it again. So it's pretty easy. I have, as you saw, I just type PDB and hit tab. So in my editor, I have a quick way of pulling up PDB at any time. So what we're going to talk about today is some of the common commands you'll use, some of the most common ones that I use on a day-to-day basis, and how to navigate the stack and see where you're at in the code and get some more advanced debugging going on. So the first thing is PDB does have built-in help. So if you just type help at the prompt or question mark, then you can see all the commands. You can also use help to get help on a command, so you can do help to get help on help. But I think if you've already used help, you probably already know what you're doing. But you can also do something like help list and see what that command in particular does. Oh, I guess I should show it as well. So I'll run this again, and I'll just type help, and then we can see all the commands we have available to us. And most PDB commands have a shortcut, so like a one-letter shortcut. So in this case, it's just question mark. We can do question mark list and see all about that particular thing. So next, showing the current context. So as you saw when we pull up into PDB at the top of the file, we just see the line we're currently on. That's not too exciting unless we know exactly what all the code is. But so we can use L to list out the code. So it'll list out the next 10 lines of code. And then you can also tell it, I want to see lines 3 to 9. And it'll show those specific lines. One thing that I find kind of annoying about PDB is when you type L again, it's going to show you the next 10 lines. So if you were doing something and you forgot what those lines were, then you have to say, okay, I want lines 1 through 10. So you have to explicitly tell it which lines you want. And there's a fix for that later we'll talk about. So that's list. It's pretty simple. It just shows you the code where you're at. You can also repeat any command that you just ran. And this will go in concert with another command here in a second. But we can just say, so if we type list and we see the code, we can just hit return, and it'll repeat whatever PDB command you did. This is particularly helpful with next. So we can go next. You can just hit return and start walking through the code. So it's a little bit easier than just retyping the command. And one thing I also want to show off, and Alex Skinner just talked about it in his talk before this, is PDB++, which is a really awesome extension to PDB. Get in the right virtual environment. So I have PDB++. You just do pip install PDB pp, because you can't install with ++, it's reserved characters. And then if we do this again, now we're already given more context because I have what they call sticky mode turned on. This is the main reason I use it, because it's pretty awesome. So now when I look at the code, it shows me what the current line I'm on, and also does code highlighting, which is really nice. So it really enhances PDB. So I'll go through the rest of the talk with this on, just so it's easier to see what we're doing. So another pretty critical thing when you're in the Python debugger is actually printing out the variables you can see in your current context, or if you're trying to figure out why some variable wasn't set to what you thought it would be, you can use print to look at those. So print or p will just print out that variable, but you can also use pp to do a pretty print, which makes things a lot easier to read. So if we go here and we list, here, let's continue on. So if we want to see what this year is, then it just prints out 2015. It's at the bottom there. So that just prints out what that variable is. So I have another variable called example that I put in my PDBRC. So this, just printing that out, it's kind of hard to read. It's a dictionary. It's kind of hard to see what the keys are, what the values are. So if you do pretty print on it, then it's a lot better. Although, so here it organizes them by key, and if that list was longer, say it was like 50 things in that list, it would actually break that out into a long list, so you can actually read the whole list in line. So it's a really nice, really handy thing. So I pretty much default to typing pp and then whatever variable or method or whatever it is. So I automatically get pretty printing output. And it's fun to say. It always gives me a chuckle because I'm like 12 years old. So I already talked about this one a little bit, but you can use in to go to the next line or next. I always use in because this is a very common one to use, so in is a lot quicker to do. So if we go here, we're at the top of the file. If we type in, so because we invoked it with the -m flag, it started at the top of the file, so it's actually running through all the imports. And as I go next, it just keeps going on down. Here it's going to read in the function. Now it's going to go down into our main method, the thing that allows us to make this a command line application. So you can kind of just see how the whole file is being processed by Python, and you can step through piece by piece, which is pretty nice. So step is another way to traverse the code. So next, we'll just keep going next, next, next. It'll go into a loop if you're inside of a loop, but it won't go into a function. So if you wanted to see what that actual function does and look inside of that, you can use the step function, or step command. So in this case, we'll stop this. I actually want to kill that. Since I already have a PDB in here, so I'm just going to run it normally. Oh, and in this script, I should probably explain a little bit. Does anyone here know what a punch key is, or a punch key? It's the most delicious thing they make right before Lent. So they got to get rid of all the good things in the kitchen, all the jams, the jellies, the fruits, and they put them in these awesome donuts, and they're the most amazing things ever. And one year I missed it. So I missed the little window you have right before Lent to actually get these delicious pastries. So I actually solved this problem with Python. So now this runs on a cron job on my server at home, and alerts me a few days before that, hey, you need to go buy some punch key. So it's been very effective. I've gained weight, so it's good. So yeah, we're going to talk about step. So here we are, we're calculating lint, and we're also trying to figure out what Easter is. So I'm using dateutil, which is an awesome library if you haven't used it. So here, right here, I'm calling the Easter function on this year, and that'll tell me what day Easter is, which is, it's a complicated process. So if I do step, it actually takes me into the Easter function, and now when I go next, I can actually see how this is all, how they're figuring out when Easter is. So then you can walk through here and see how they calculate that. And so it's obviously not a very easy thing to figure out, because this looks crazy. So step is really powerful. So if it's code you didn't write and you're using a framework, you can actually step into the framework's code and see how they're actually doing something without having to go dig up the source code to actually look at it. You can actually walk into it. And here we can also we can use pretty print. So the year is what we passed in. I don't know why they're assigning that to y. Maybe not the greatest example of coding with a lot of single letter variables. Especially C down further is actually a PDB command, so it'll actually throw you off. So that's another reason to use pretty print or print, because sometimes you might run into some code that is using a variable that's actually a PDB command, and when you actually try to print it out, because I can type just y and it gives me the year, but if I was at a point where I was like in, it would actually just go to the next line instead of actually printing out in. So that's a good reason to always just use print or pretty print. So yeah, so then we can just continue through. So that's step. Next is until, and that's actually not correct. Let me regenerate my slides real quick. The power of open source and plain text. There we go. Now it is correct. So until will give us a way to sort of get through a loop without having to go next, or set another breakpoint. So here I have an example.py. So I have this file here. I got a PDB trace in it, and I'm just looping over os.lister. So if I run that command, so run this Python code, as I go next, you can see it's in the listing loop, and now it's printing out all the items in this directory. So if I wanted to go to line 11, I could use a breakpoint, but I could also just use until. So if I type until, actually move. So now I'm at the end of the loop, and if I type until one more time, it actually prints out the rest of the loop and takes me to the next line. So you don't have to do anything else. You can just use until to get outside of that loop and continue debugging that bit of code. Especially if you're getting into really like nested list comprehensions or things like that, this is an easy way to get through that. You can skip to an end of the function as well, so you can just use return. So if you're in a method, you can just use return or R to get to the end of that method and then go from there. So if you're traversing through a bunch of different code, there may be functions you don't care about, but you want to get to the next line of execution without having to set another breakpoint. So you can do that by using return. So I will show that off and go here. So right now we're inside of the main function, and if we type return, it takes me to where this method or this function actually ends. And because we're not yet to the window of time to buy punch key, it's actually going to give us it's going to exit out of the script with sys.exit. So we can actually see that here, and we can actually see the return value at the bottom. I don't know if you can see that, but it'll actually show you what the return value was as well. So you don't have to actually investigate what it actually returned. And in this case, it didn't return any a variable or anything. So it just gives you the return value that you can inspect from there. So breakpoints, another really handy feature. So we've seen me just set a set trace with the PDB module. But you can also set breakpoints while you're in the debugger. So if there's different parts of the script or module that you want to debug, you can actually set those breakpoints with break or B for shortcut. And if you just type B, it'll show you the current breakpoints. And then you can type B and then a line number, and you can set a breakpoint at that point. You can also set a breakpoint in another file. It's a little more difficult because you're not, there's no like command line completion. You have to know the name of the file and know the line number and all that. So let's look at that real quick. So if I type, well, here, I should start this over. So if I type B right now, there's no breakpoint set. But if I set a breakpoint at line 16, then I type B, I can see the number of the breakpoint, which is the one we just set. That's useful later if we want to clear it out. The type of breakpoint, and then where it's at, and then after it's run, so if we continue, and we type B again, it'll tell us how many times it hit that breakpoint. So that's especially useful with the conditional breakpoints, which I'll show here in a second. So you can see if it actually did hit your breakpoint or not. Because you could set the breakpoint and not actually hit it, and this would tell you if you hit it or not. So once we've set a breakpoint and we want to clear it out, so maybe we set it in a loop and we don't want to hit that breakpoint every time, we can actually use the clear or CL to clear it out. So I know the number is 1, so I can say CL1, and now there's no more breakpoint set. So this is really handy when you've started in one place and you realize you want to stop in some other place to debug things. Continue is also important. So once you're inside of the code and you're done looking at it and you don't want to do anything else, but you want to continue the execution, you can type C. So say you were debugging a view in a pyramid app or something. When you hit your breakpoint, the system's waiting for you to finish that debugging session. And if you type C, it'll continue executing the rest of the code and give you the results of whatever was happening. So that way you can actually change things in the debugger and then see how that results. So we've seen this a little bit, I think. So here I'm on line 12 because I have a PDB set trace. If it also will go to the next breakpoint. So if I set another breakpoint at line 16 and type C, it'll continue till the next breakpoint. And then if I type C again, it's going to continue on throughout. And I don't know why I got an error. This has no tests, so it works, I know that. So C just gets you through the rest of the execution. You can also do conditional breakpoints. This is really handy if you know a certain way that the application may break, and you can actually set an expression. You can say, I want a breakpoint at line 11 with this expression, this year equals 2015. So this is super handy, especially if it's a loop and it's looping over hundreds of thousands of things. You can actually get to that one point you want that breaks it. So here in this case, let's do this again. And actually I need to move my breakpoint. So I'm going to move this to the top of the method. So now I want to set a conditional breakpoint based on the year. So I'm going to set it for 2014. So on line 11, if the current year is 2014, it's going to stop. But if it's not, it's going to keep going. So we can look again. We can see stop only if this year equals 2014. So you can see what you actually set as the condition. And now if I continue through, you can see that the breakpoint was hit, but this year is not actually 2014, so it shouldn't have stopped, but it did. So let's pronounce year, or this year. Okay, let's try this again. Oops. Actually, I need to edit the file. So I'm going to take this out. I'm just going to do it with the PDB module. And now I will set the breakpoints. There we go. I'll continue. So breakpoint already hit one time, but we're still at the top of the file. So it didn't actually stop on that condition because it's 2015. So if we change that to be 2015, then we can see we have 2 breakpoints. This one hasn't been hit yet. If we continue through, now we've stopped at line 11 because this year is 2015. And if we look at the list here, we can see the other breakpoint was hit twice. This one's hit once now. This is a really powerful feature to stop exactly where you want to stop in your code. Another really powerful thing is being able to navigate the stack. So where will tell you where you're at in the current stack. So if I go next and step into this function, so now I'm inside of the date util code. If I type where, then here, let me do it again. This shows me where I am currently, which is the bottom line, and then all the things it's called up the stack. So if you're in a web framework or something, this could be a very long list of things. In this case, I'm just calling one other Python package, so I'm pretty shallow in the number of things we have here, but it still can be useful if I want to debug what's going on. So you can go up and down the stack. So once you know where you want to be in that stack, you can use up or down or U or D to do that. So if I go up, now I'm back to where I started. But then I can also go back down. I can go all the way to the top. And then could not get the source code, so that's interesting. So then if I type where again, you can see, it's kind of hard to see, but there's like little arrows, but then there's the greater than that tells you where you're at in the stack now that you've gone up and down. There's some new features in Python 3. The interact command gives you a Python console inside of PDB with the current scope. So if anyone's ever been in the PDB prompt and tried to do something like an if statement or like create a class or create a method, you can't do that. But in Python 3, they've added the interact command, and that will actually drop you into a Python prompt, and you can do more advanced Python things with it there. And actually, PDB++ also adds that feature. So now it's dropped me into a Python prompt, and it's given me everything that we have there. So this year, actually I don't know where I'm at. Let me go back down. And so then you can create a class, create a method, do all more advanced things from there, which is nice. Another feature in Python 3 is long list. So you remember me griping about list always going to the next 10 lines. Long list will show you the full method of what you're in. And actually PDB++ has this as well. So if I type, at least I thought it did. Oh, I'm in the console. Clear that. So now it's showing me, well, as much as it can of the current function I'm in instead of list, which just keeps going through the file. So it's a really, really handy command that got added in Python 3. And when you're done, you can actually quit. And this is sort of the opposite of continue. So where continue continues and does the rest of the execution, quit will just quit out of PDB and stop the execution. So if you did something, you're debugging something where you don't want it to actually execute that code, you can use Q to quit out of it. Something might write to the database or do something you don't want it to do, you can actually use Q to stop execution. So in this case, if I run this, it actually just quits out at the beginning instead of looping through. So with continue, because I started with a -m PDB, it just keeps running it with PDB. If I do Q, it automatically just jumps out. There's some PDB alternatives, so I showed off PDB++, which is nice. Another popular one is IPDB, so it's IPython and PDB together, so it gives you more tab completion, some better, nicer features like that. I don't really use IPDB that much, and I actually don't use PDB++ that much either. Typically, I'm using just PDB, but I do like using PDB++. I forget to use it. But it's really handy, especially for that sticky mode. I really like that. If I'm going through a very long debugging session, I will actually install PDB++ and use that to do things. There's also RPDB and remote PDB. I'm not sure which ones maintain more than the other. This allows you to get a Python or PDB prompt inside of a remote process. So if you're using something like Celery or something that's asynchronous, you can actually put a PDB in there and then run a command on your computer, and it'll connect to that once it hits it, and then you can debug that remotely. So that's a really powerful tool as well. There's some helpers. There's PDB Sublime Text support, which will actually show you what line you're on in Sublime Text, and there's something else for TextMate. There's Vim PDB, which gives you interaction with Vim, a similar thing. There's actually Flake8 Debugger, which is a Flake8 plugin to warn you when you've left a PDB in your code. Because if you do that and release to production, you've done terrible things. And there's also a way to personalize your PDB, the PDBRC, so you can actually set up aliases and custom mappings. And if you don't want to install like an iPDB or a PDB++, you can actually enhance the readline support via that, which is nice. And then I put a couple links, and I'll put these slides up and tweet those out. The Python Module of the Week by Doug Hellman has a really extensive write-up on PDB. It goes over pretty much everything. There's some things I wasn't able to get to, which is like time travel, which obviously sounds complex. That's why 30 minutes was not enough to talk about time travel. So that's all talked about there. And then last year, Nathan Yergler gave a talk called In-Depth PDB here in Montreal. It was really good. So I suggest you go watch that as well. And that's it. Thank you.
So if you have any questions for Clayton, there is a microphone in the center of the room. Just see if there are some people who want to line up. Yes, indeed there are. First question, please.
Is there a way to monitor for variable change in PDB?
Like to watch a variable?
Yeah.
I've not used that function, so I don't know. There might be, but I'm not certain there is.
Okay, thanks.
Yeah, next.
So I noticed you had some kind of power line thing going on at the bottom there. Where did you get that?
That was inspired by Wemux. So that's a Tmux shell.
Yeah.
So
okay.
I just
oh,
stole
okay.
it
So that's not PDB++ doing
No,
that.
that was just
okay.
my shell.
Cool.
Yeah.
Hi. I'm a novice in general. My experience with debugger includes the Eclipse and PyCharm GUI-based debuggers. Do you have any sort of argument for me to try switch to something like PDB from my GUI-based debugger, or is it just subjective, opinion-based?
Yeah, I mean, I think if you're already happy with using it inside of Eclipse or whatever, I think that's fine. If you're trying to debug something on a remote machine, you don't have access to the GUI environment, then you would want to use PDB through the command line. But that would probably be the only reason.
It's still a good talk because even if you use the GUI, it's like everything you said, I think there's an analogous thing to do on a GUI debugger. And I had not, gone as far as some of the things you described. So I think it's still pretty applicable.
Okay.
We'll take these last two people who are in line now.
Thanks for the
That's all I've
talk.
got time
It was good. Does PDB have a way to trigger on raised exceptions automatically, or?
There are some people have written packages to do postmortem debugging, so it can do postmortem,
Okay.
and so you can. I think you can. I forget what the flags are, but you can start programs usually with that flag, and then they'll do that for you.
Okay, thank you.
Okay, this will be our last question.
Okay, great talk. I was wondering, is there a way to customize the number of lines you see when you break? Because I think I use iPDB and I don't see like 30 lines that you see.
Well, in PDB++, you probably there's a lot of options in PDB++. In regular PDB, you could probably make aliases to do all that stuff. Like list, the next so many lines. But by default, I don't think there is.
Okay, thank you.
Right, everybody, please thank Clayton Parker.
Thank you.